What's up? I'm Vin, and today I want to go through the AP Calc 2008 BC multiple choice no calculator section. So first up here we have a particle moving, and we're given the velocity vector over here, and we want to know what the acceleration vector is specifically at time t equals 3. So the first thing we need to know here is that the acceleration vector we get by taking the derivative of the velocity vector. So we take the derivative of the x component, t squared, the derivative is 2 times t. And the derivative of 5t is just 5. So now when we want to say what's going on at t equals 3, just plug in 3. And we have a of 3 is equal to, and we have 2 times 3 is 6, comma, the 5 is constant, so that just stays. And this is going to correspond to choice B. So now moving on to the next one here, sometimes it could be a little bit tricky to determine if you're going to use integration by parts or u substitution. So here, if we let u equal x to the second power, notice that du is 2x dx, and if I divide both sides by 2, that tells us that 1/2 du is equal to x dx. So this is going to be a u sub situation because we have an x in front of the e to the x squared here. If it was x e to the x, then we would do integration by parts. So now we just have to make the substitution that this is going to be the same thing here as the integral of, we would have, instead of x e to the x squared dx, we're going to have e to the u, and notice the leftover x dx we could just replace with 1/2 du. So this just goes in front like this, and now the antiderivative, we have 1/2 times the antiderivative of e to the u is e to the u plus c, and then just plug back in for u is equal to x squared. So here's our antiderivative, and it's going to be the first choice here, choice A. Now just know, if you get nervous for a question like this, you could just by brute force take the derivative of everything. So you would have to take the derivative. The newest AP exams only have 4 answer choices. This is an older exam, but still very relevant topics. Okay, but you could theoretically just take the derivative of everything, or just know how to do the antiderivative by u sub. So now for the third question here, we have the limit as x approaches 0. And my favorite way to go through a question like this is something that you could just show up to the test knowing, is that the limit as theta goes to 0 of sine theta over theta is equal to 1. So this one here, be careful. Someone might choose choice E, but this is a trap. The person who chooses choice E is going to plug in 0 and get 0 over 0 and say, oh, the limit doesn't exist. But remember, this means the limit is an indeterminate form and you have to do something else. So this, if we group it a little bit different, we could say is sine x over x times cosine x. And now, check it out. It uses this famous formula here. The limit as x goes to 0 of sine x over x, this whole piece here is going to go to 1. And then this is going to go to cosine 0 because cosine is a continuous function. And then cosine of 0 is 1, so this just works out to 1. Just know for something like this, if you don't know that formula, that's okay. You also have the option of using L'Hopital's rule here. But this is a nice way to do it, just knowing this formula. For question 4, we have this series, and we're applying the ratio test. And we have to say which of the following inequalities is going to result from this. So to apply the ratio test, we know our a sub n term here is e to the n over n factorial. And to apply the ratio test, you have to look at the next term, a sub n plus 1, which you could find by replacing each n with n plus 1. So this would be a sub n plus 1. And the ratio test, we're doing the limit as n goes to infinity of absolute value, and we have a sub n plus 1 divided by a sub n. But when we divide by a sub n, it's a fraction. That's the same thing as multiplying by the reciprocal. So that gets us to this step. So now we go through with the algebra here. E to the n plus 1 over e to the n is going to simplify to just e to the first. And this is because n plus 1 is exactly 1 more than n. And now n factorial over n plus 1 factorial, I'll show that on the side. But this simplifies pretty nicely. N plus 1 factorial, we could expand to n plus 1 times n factorial. So the n factorial on top will cancel out the n factorial on bottom, and we'll be left with just n plus 1. So once again, this is going to cancel with this, and we'll be left with just n plus 1. So now what we have here is this is equal to the limit as n goes to infinity, and we could get rid of the absolute value because e is positive, and n plus 1 is going to be positive as n goes to infinity. So this we could just call e over n plus 1. And for the ratio test, to apply the ratio test and find something that converges, you need your limit to work out to a value less than 1. So we just set this whole thing to be less than 1, which matches all the answer choices. But now we just have to look for the e over n plus 1, which is going to result in choice D here. For question 5, we want to find the length of this parametric curve, and we have the equations given here, and we're going from 0 to pi. So it's very important to show up to the AP test knowing all your formulas. So for something like this, to find the length of a parametric curve, we have the integral from t1 to t2, and we have the square root of, we've got dx dt squared, and then we've got plus dy dt squared. Now, it really helps if you want to do well on the AP test to look for connections, and it's definitely no coincidence here that this is also the equation for speed, and the integral of speed tells you total distance traveled. So this is directly related to the concept of finding total distance traveled. So for this one here, what we have to do is we also have to know how to do the chain rule because we're going to find dx dt. Just note, there are so many questions on the AP test that use chain rule, so you have to show up knowing chain rule. So the derivative of sine t cubed, we have the derivative of the outside is cosine. So we keep the inside as t to the third. And now the derivative of t to the third, let's just make that a little neater. So we have t to the third, the derivative of that is 3t squared. And now we've got dy dt, the derivative of the y equation, we also have to use chain rule. The derivative of e to the 5t is going to be e to the 5t, but then we just have to multiply by the derivative of 5t, which is 5. So now we are going to plug into this equation here, but notice we have to square dx dt and also dy dt. So we'll do that at this step. So we have this thing squared, and we're going to square the right side as well. And we're going to do the same thing for dy dt. We square the left side, so now we have to square the right side. So now we just plug all of this in. The length is going to be modeled by, we have the integral from, this is t1 and t2. So we're going from 0 to pi. And now we have a jumbo square root. And now just be careful squaring this stuff. So you're going to square each term. So 3 squared is 9. T squared squared, we're just going to do 2 times 2 is 4. So we have t to the 4th. And be careful with this piece. We have cosine t to the 3rd squared, or times itself, is going to give us cosine squared of t to the 3rd. Don't make the mistake of squaring t to the 3rd, but there would be no answer choice to distract you if you did do that. So now we have plus, and now we're just going to attach the dy dt squared. So we have 5 squared is 25. And then we've got e to the 5t squared. We're going to multiply 5t by 2, and we're going to get e to the 10t. And there's a dt at the end. Remember, notation doesn't matter for multiple choice, but we'll just practice good notation. So now we just have to look and try to match this. So that's going to work out, looks like, to choice C for question 5. So for question 6 here, we have f defined by this piecewise function here, and we want to know which of the following statements are true. So I personally, for the questions with the Roman numerals, just go through them one at a time and see if they're true or not. So f has a limit at x equals 2. So here we just have to take the limit as x approaches 2 of f of x. And if we're going to approach 2 from the left and right, we're going to use the piece where x is not equal to 2, because that means we could get really close from the left and right. This is only a single point, so it's not really helpful for finding limits. So we're going to plug in the part of f of x once again where x is not equal to 2, so we could get close from the left and right. And for a limit like this, you could go through with this a few ways, but we could just do this algebraically, that this is the limit as x approaches 2, and if we factor the top, it's going to be x plus 2x minus 2, because we have a difference of 2 squares, over x minus 2. And now these are going to cancel, and we just plug in 2 for x, and we're going to get 2 plus 2 is equal to 4. So our limit does exist, so this is in fact true. So that eliminates choice B, and that's going to eliminate choice C as well. So now we just have to go through the other ones. Now f is continuous at x equals 2. You have to know that if a function is continuous at x equals 2, that means the limit as x approaches 2 of f of x is going to be equal to f of 2. So the next thing we should find here is, what is f of 2? F of 2, they told us, is equal to 1. So right away I look at this and see, wait, the limit is equal to 4, and the function value is equal to 1. So in this case, this is not true. So automatically f is not continuous at x equals 2. But now that tells us, without doing much work at all, we could just say right away, f can't be differentiable at x equals 2. Because remember, if a function is differentiable, that implies that a function is continuous. All right, so if f is differentiable, that means f is continuous. So the reverse and negation of this statement is also true, like f not continuous. So let me just make sure that's a little bit neater. So f not continuous implies that f is not differentiable. And I'm just going through this quickly. I know this is not grammatically awesome, but if f is not continuous, that automatically means that f is not differentiable at that point. So that means for this question here, only Only one is true, so we're going to go with choice A. So for the next question here, we have y of 1 equals -3. We have dy dx, and we want to know an approximation for y of 2, and we're going to use Euler's method with the step size of 0.5, and we're starting at x equals 1. So for questions like this, I like to make a table. So I have a table with x, y, and dy dx. So they start us off here with the point 1, -3. And we're trying to approximate y of 2, which means what is the y value when x is equal to 2? So we're using a step size of 0.5. That means we're going to do 2 steps, because if I go forward 0.5, the next value would be 1.5. And if I go forward 0.5 again, that brings me to x equals 2. So the way this method works, and I personally once again like to use the table, is we have to write the equation of a line using this point, and we have to know what is the slope at 1, -3. So that's where the derivative comes in. The derivative tells you the slope of your line. So we're going to have dy dx, and just know this notation here with the vertical bar, it's multiple choice, so your notation does not matter. But just for the sake of explaining this, I'm going to say with this notation, so we know we're plugging 1, -3 into the derivative. So I'd have 2 times x is equal to 1 plus y is -3, and this is going to give us 2 minus 3, which is -1. So that gives us our first slope. And then once we find our first slope, we're going to write the equation of a line using y minus y1 equals m times x minus x1. So, and notice here, I could just add y1 to both sides. So I could just say that this is y equals m x minus x1 plus y1. Okay, so this is the better one to use because it's already solved for y. So I'm going to use that right now. So I have y equals, our first slope is -1, and then we have x minus 1 plus y1 is -3. So I could say plus -3, or I could just say -3 like this. So now what we're going to do is we're going to plug in 1.5. So we have x equals 1.5. That tells us we're going to have y equals -1.5 minus 1 minus 3. And then this is going to simplify to, this works out to 0.5. So I have -0.5 minus 3 is -3.5. So now that's my next y value, -3.5. And then I start this process all over again. So now I plug these 2 points into our derivative. So we'll just say here that at the point 1.5 comma -3.5, y prime, or our derivative dy dx, is equal to, we have 2 times 1.5 plus y, so I'd have minus 3.5, because that's the value of y. And now this is going to give you 3 minus 3.5, which is -1/2, or -0.5. So that's our new slope, -0.5. And now I'm going to write the equation of a line again, except I'm using this point and this slope. So next we would have, using this equation here, we have y equals, the slope is -0.5. I have x minus, the x value is 1.5. And then I have plus y1, which is minus 3.5 in this case. So the last thing I need to do now is just plug in x equals 2. So if I plug in x equals 2, this tells us our y value is -0.5. And then I have 2 minus 1.5 minus 3.5. So what this is going to give us here, I'll just simplify this over here. This is -1/2 times 2 minus 1.5 is 0.5. So if I do -1/2 times 1/2, that's -1/4, or just think 5 times 5 is 25, but it's going to be after the decimal. So I'd have -0.25 minus 3.5, and when I simplify -0.25 minus 3.5, that gives us -3.75. And that's going to be our approximation for y, and it's going to match up with choice D. For question 8, we're doing a left Riemann sum, and we have 4 subintervals breaking up the interval from 2 to 13. And we want to approximate the value of this definite integral here from 2 to 13 of f of x dx. So this here, what you could do is you could find the 4 delta x's. So the first delta x from 2 to 3, this is the first subinterval, is going to be a distance of 1. And then the second delta x sub 2, is going from 3 to 5, and that's a space of 2. And then delta x sub 3 would be the space from 5 to 8, which is equal to 3. And then the last one, delta x sub 4, would equal 5. That's the distance from 8 to 13. So when we set this up, now we're doing a left Riemann sum, and we have 4 subintervals. That means we're going to be using the 4 y values to the left. and we're going to leave out 9. This is not going to be included in our Riemann sum here because it's a left Riemann sum. So now we go ahead and apply this. So we have 6 times our first delta x is 1, because that's the space from 2 to 3. And then we have plus our next y value is -2, and the second delta x is 2. Plus, and then we have our next y value is -1. See, that's the next y value in our table. And our next delta x is 3. And then finally, our last y value we're going to use is 3 times our last delta x is 5. So then we just have to simplify this carefully. So this is going to be roughly equal to 6 minus 4 minus 3 and then plus 15. So this is going to give you 6 minus 7, which is -1, and -1 plus 15 is equal to 14. So this is going to be choice B. For question 9, we have g of x is an area function, and we want to know which of the following values is greatest. So we want to find the maximum value of g. So if you think about this, g of x is an area function, and it's the area under f. So this is an area function, and the integral starts at -2. So when you think about it, as soon as we start moving to the right, if we look at the area under the curve starting at -2, as we start moving to the right, let's say at x equals 0, you see we have positive area accumulated because we're above the x-axis. And then the moment we hit 1, we have more positive area, but the second we go to the right of 1, we have area under the x-axis, which this counts. We technically can't say area is negative because as a geometry concept it can't be negative, but this is negative signed area for definite integrals. So at 1 is when we're going to hit our maximum, because the moment we move past 1, we're going under the x-axis and we're losing that positive area we accumulated here. Now the other way of thinking of this, there's a second way to get to the answer that's a little bit more technical. It involves more work, but you can get through this question quickly using the reasoning I just used here. But when you want to find the maximum value of g, you could take the derivative of g, and you get g prime of x is equal to f of x. And this is by FTC, Fundamental Theorem of Calculus, usually part 2 in most textbooks. And then you use the first derivative test. You say, okay, I want to set g prime of x equal to 0, and g prime equals 0. This is the same thing as f, so you look for when is the graph of f equal to 0 at x equals 1. So this is true when x equals 1. And if we make a sign chart, this graph only goes out to -3 and stops here at x equals 2. So at x equals 1 is our only critical point, and the graph is above the x-axis before 1, so we have a positive g prime, and then between 1 and 2 the graph goes negative. So because our only critical point makes a local max, if you only have one critical point and it's a local max, it's also the absolute max. So that tells us g of 1 is the absolute max. Okay, so this is using the first derivative test. But remember, the first derivative test only tells you local extrema, except if you only have one critical point. I like to use the example of a parabola. A parabola only has one critical point, so not only is this the local maximum of the parabola, it's also the absolute maximum because it's the only critical point. For question 10, we're finding the slope of the line tangent to this curve, and we're at the point 2, 1. So this is just all technique. We're going to be finding the derivative. So we're taking the derivative with respect to x of this equation, and we have to use implicit differentiation. So the derivative of x squared is 2x. And if you can't do this part in your head, that's okay. This is going to require product rule. And the product rule, if you have uv prime is equal to u prime v plus uv prime. And if we define u and v here, u would equal x and v would equal y. But we have to be careful. The derivative of x is 1. But the derivative of y, we're not going to just say 1. We're going to say 1 dy dx because we're taking the derivative with respect to x. So now we apply the product rule. So our derivative is going to be uv prime. I could write that first because addition is commutative. We could switch the order. So I have plus, because I did the derivative of x squared is 2x. Now we have plus the derivative of xy is x dy dx plus, and then we have u prime times v is 1 times y, or just y. And then we have plus the derivative of y squared is 2y, but we have to tack on dy dx. Okay, remember the concept behind this idea is that when you take the derivative with respect to x, that's the same thing as taking the derivative with respect to y. and multiplying by dy dx. So when I take a derivative of a y term, I get that extra derivative piece at the end. And now the derivative of 7 is 0. So because this is multiple choice, your notation is not important. You could just plug in x equals 2 and y equals 1 right away. So we're doing 2 times 2 here is 4, plus x equals 2. So we have 2 dy dx. And then we have plus y is equal to 1. And then we have plus 2 times y is still equal to 1. So we have 2 dy dx. And this is equal to 0. So now I could just combine like terms. I have 2 dy dx plus 2 dy dx. If we bring that over here, that's going to be 4 dy dx. And then we have 4 plus 1 is 5. So I have plus 5 is equal to 0. Now a little bit of algebra, subtract 5 and divide by 4. So dy dx here is going to be equal to negative 5/4. So this is going to match up with choice B. So this is a real nice question. We have R is the region between y equals e to the negative 2x, the x-axis, for x greater than or equal to 3. So I would just sketch this out. When you have y equals e to the x, it goes like this. But when you have y equals e to the negative x, or in this case y equals e to the negative 2x, that's just going to be a curve that looks like this. And we're looking at the region where we're going greater than 3, and we're between the curve and the x-axis. So this is actually going to be an infinite space to look at here. But the million-dollar question is, does the area under the curve converge, or does it diverge? Does this get to the x-axis fast enough, or does it not get to the x-axis fast enough? So what we're going to be finding here, this area could be modeled by the integral from 3 to infinity of e to the minus 2x dx. So this is an improper integral, so we're going to swap out infinity with, we have the limit as b goes to infinity of the integral from 3 to b, and we have e to the negative 2x dx. Now, anytime you have an integral with e, it's really helpful to know this little shortcut. If it's e to a constant times x dx, the antiderivative is 1 over the constant e to the kx plus c. Now, in this case, it's a definite integral, so we don't need a plus c, but this is just really helpful to know. So this is now equal to the limit as b goes to infinity of the antiderivative of e to the minus 2x. We could just use this formula in k equals negative 2. We would have negative 1/2 e to the negative 2x, and we're evaluating this from 3 to b. So we have to use the fundamental theorem of calculus here. So what I like to do with these kind of questions is I take the constants out. So negative 1/2 I write in front of the limit, and I have the limit as b goes to infinity of, and we're going to have e to the negative 2b, and then minus e, and if I do negative 2 times 3, that's going to give us negative 6. So we're just plugging in here. So now I just have to simplify this a bit. This is going to be equal to negative 1/2, and we have the limit as b goes to infinity, and this I could just rearrange a bit. This is 1 over e to the 2b minus 1 over e to the 6. Now, as b goes to infinity, 1 over e to the 2b is going to go to 0 because I have 1 divided by infinity. So I'm going to have negative 1/2 times 0 minus 1 over e to the 6. So if we distribute here, negative 1/2 times negative 1 over e to the 6 is equal to 1 over 2e to the 6th power. So now we just look through the answer key, and this is going to be choice A. For question 12, we have a few strategies here, but we want to find for which of the following series does the series converge for all real numbers x. So the painful way to do this would be to do the ratio test to all of these, but my best strategy here is to just plug in. So let's say I plug in something easy like x equals 1. If we plug in x equals 1 to choice A, we're going to wind up with the series 1 to the n power is just 1 over n, and this is the harmonic series which diverges. So this one clearly does not converge for all values x. It diverges at x equals 1. So A is out. Now, same thing again. If you plug in x equals 1 here, you're going to get 1 over n squared, and you may say, oh, this is a convergent p-series. But now we're going to plug in a bigger value of x. Let's say we plug in x equals 2. So if we plug in x equals 2 to choice B, that's going to give us the series 2 to the n power over n squared. And now we have an exponential on top versus a power function on bottom. So we could use the nth term test for divergence to show that this one diverges. So this series is going to diverge by the nth term test because the exponential is going to outpace n squared as n goes to infinity. So this is out. This one, same argument. We could use x equals 1, and that's going to give us the series 1 to the n is 1 over radical n is n to the half, and this is a divergent p series because p is 1/2, which is less than or equal to 1. So this one does not converge for all x. Now, this one here is going to be the answer that it's choice D. And one thing that jumps out at me right away is that there is a factorial on bottom. And just know that factorials are more powerful, or they increase faster. Factorials increase faster than any of the other functions they throw at you except n to the n. Okay, so like the order behind things here is like n to the n is the most powerful, then n factorial, and then something like 2 to the n or x to the n is next in line. And then if you have something like n squared, like that's not as powerful as 2 to the n, which is not as powerful as n factorial, which is not as powerful as n to the n. So the fact that we have, in a sense, like ex to the n on top, factorial wins. So factorials increase faster than exponentials. So this idea is really, really big. So if you look at choice E, why this one is out is because the factorial is on top in the numerator. So the numerator is going to outpace the denominator. So by the nth term test, this is going to diverge. So this is definitely choice D. So next question here, we have to do a little bit of algebra first. So I would rewrite this as the integral from 1 to e, and I would do x squared divided by x plus 1 divided by x. So we could split up the numerator. Just know one thing you could never, ever, ever do. Don't, and I'll just make sure I write the word don't, so I'm not saying this is true. If you had x over, let's say, x squared plus 1, this is not equal to x over x squared plus x over 1. This is never allowed, so just don't ever do that. This is really bad. So when you have a numerator in multiple pieces, though, you can split it up like this. All right, this is fine, this is not fine. So now this is equal to the integral from 1 to e of, you have x squared over x is x plus 1 over x dx. So this is much easier to do because now we just do power rule and then we do natural log for this one. So the antiderivative of x is 1/2 x squared plus the antiderivative of 1 over x is natural log absolute value x, and we're going from 1 to e. So now we just plug in, this is 1/2 e squared plus natural log absolute value of e is e minus, and now we plug in 1, we have 1/2 1 squared plus natural log of 1 is 0, so this piece cancels out. So now this is going to be equal to, we have 1/2 e squared plus natural log of e is equal to 1, and then we have minus 1/2. So what this is going to give us, this is going to give us 1/2 e squared plus 1/2, and notice here our answer doesn't show up, but we just have to make common denominators here, which we already have. So this is e squared over 2 plus 1 over 2. And if I do, I'll write it over here in a different color. If we have e squared over 2 plus 1 over 2, I don't know why I wrote e, we have 1 over 2. This is going to be equal to e squared plus 1 over 2. And that's going to give us choice B. Question 14 is a really good question because we're going to get stuck between two answer choices for a moment. Now, we have the values of the second derivative in this table above. And we want to know which of the following statements, the million-dollar phrase here is must be true. So f is increasing on the interval. F is increasing comes from the first derivative. So the second derivative being positive or negative just tells you if the curve is concave up or down. But if your curve is concave up, it could be decreasing or increasing. And the same thing for concave down. You could be going up or down. So A is out because that relates to the first derivative. And by the same logic, B is out because the second derivative doesn't tell you if your curve is going up or down. But now, choice C is another one you have to really make sure you know your theorems. Local maximum at x equals 1. I know we have a 0 here, but it's the 0 of the second derivative. So zeros of the second derivative tell you something about points of inflection, not local extrema. So this one is out. So now we're between choices D and E. Now, if we look at this carefully, this is going to be choice E, and I'll explain why it's E, and then I'll talk about why D is not a scenario that must be true. So choice E, f changes concavity in the interval from 0 to 2. Notice that f double prime of 0 is equal to 5, and f double prime of 2 is equal to -7. The only way for us to go from 5 to -7 is we have to pass through 0. So we have to go from 5, at some point we have to hit 0, then we have to go negative. So we have to go from concave up to concave down at some point between 0 and 2. So that's how we know the graph of f changes concavity in the interval 0, 2. So now, what we have next is why is choice D no good? So choice D is no good because some people who choose choice D say, well, there's a 0 here and we change from positive to negative. But one thing to be careful with, so now I'm going to add something to the table. Let's pretend for a moment that at 1.1, the value of our second derivative was equal to 2. So then we would not have a sign change surrounding the 0. So if we look here, there's no sign change at this point. So this would be a scenario where we don't have a point of inflection at x equals 1. Now at some point we would need to have a point of inflection. So let's say there was another value in the table, x equals 1.5 gives us another 0 of f double prime, and then finally we go from positive to negative in our second derivative. So we do have to have a point of inflection on the way from 0 to 2, but it doesn't necessarily have to occur at x equals 1. So that's why this one, once again, is a tempting answer choice, but it's possible that it's not true. So this question here, we just have to know the chain rule and be careful. The square is attached to the entire natural log x. This is not natural log of x squared. So f prime of x, we're using chain rule. The derivative of the outside, we're doing power rule. So we have 2 times natural log x to the first power times the derivative of the inside is 1 over x. So this is equal to 2 ln x over x. So now to find the second derivative, we have to use the quotient rule. So we have f double prime of x, and we have the low function. We have 2 times the derivative of 2 ln x is 2 over x. So we're just doing the derivative of 2 ln x, which is 2 times 1 over x, which gives you this. Minus, and then we have 2 ln x times the derivative of x is 1. So we have just times 1 here over x squared. Now x over x is going to cancel out, and this is going to equal 2 minus 2 ln x over x squared. So now what we want to do is we're going to plug in square root of e. So we have f double prime square root of e equals 2 minus 2 natural log, and square root of e, we could rewrite this as e to the 1/2 power. So instead of saying square root e, I'm going to say e to the 1/2. That's going to allow us to simplify a little bit nicer. And then we have square root of e squared like this. So this is going to simplify to 2 minus the 1/2 could come out because it's inside the log function. So we have 2 times 1/2 times natural log of e over radical e times radical e is e. And then what we have here, natural log of e is equal to 1. And 2 times 1/2 is also equal to 1. So we have 2 minus 1 times 1, or 2 minus 1. And I'm just going to write the final result up here. 2 minus 1 is 1 over e. So our answer to this is going to be 1 over e, choice A. So this question here, there's 2 main ways to go through with this. So for this one here, you want to know for what values of x does the series converge. And for this one, you could do the ratio test, or you could recognize here that this is a geometric series because we have a general term raised to the n power like this. So now what we know about a geometric series, when we have r to the n like this, the absolute value of r has to be less than 1. So we could take the inside here and say the absolute value of 2 over x squared plus 1 has to be less than 1. So if we think about this carefully here, the only way this fraction, the absolute value of it, it's going to be less than 1, is when the denominator is bigger than 2. So we need x squared plus 1, the denominator, to be greater than 2. And for this to be true, x squared, if we subtract 1 on both sides, has to be bigger than 1. So now just think about the graph of x squared, the parabola. So if you look at this graph here, when is x squared greater than 1? Well, twice it'll happen. On the interval here from 1 to infinity, so as we go x greater than 1, strictly greater than 1 too, and then also if x is less than negative 1, our curve is going to go above the line y equals 1. So that means, once again, we have x is less than negative 1, union x is greater than positive 1. And this is going to match up with choice D. What I would do for a question like this is verify that the other answer choices are no good. So let's say I tested out a value like x equals 0. And this is the second method. Just plug in everything from the answer choices. If you plugged in an x value between negative 1 and 1, like 0, you see how this would give you the series 2 over, you would have 0 plus 1, and all of this to the n power. So this would be the series 2 to the n power. And by the nth term test, this diverges because 2 to the n just becomes enormous as n goes to infinity. X greater than 1 only, well, all you'd have to do to prove this one wrong is you have to come up with an x value that works. So pick an x value less than negative 1. If you plug in something like x equals negative 2, that's going to give you the series 2 over, and if you have negative 2 squared, that's going to give you 4 plus 1 to the n power. So this is 2/5 to the n power, and this is a scenario where the r value, the absolute value of it, is less than 1. So this thing would converge. So here's a value of x that's not on this interval that gives you something convergent. So this is incomplete. X greater than or equal to 1 is no good because x equals 1 gives you something that diverges. And also, we already saw x equals negative 2 gives you something that converges. So just like that, this one is out. Now, letting x equals 1 will disprove choice E because choice E is almost the same thing as choice D. So if we plug in x equals 1 here, notice we're going to have the series 2 over, and if you plug in 1, you have 1 squared plus 1 is 2 to the n power, and this is the series 1 to the n power, which is just 1 plus 1 squared plus 1 to the third, and so on like this, which will definitely diverge. So that's why 1 and negative 1 can't be included. So definitely choice D here. For 17, just have to know the chain rules. So you're taking the derivative f prime of x, and you're going to do the derivative of the outside function h is h prime. Keep the inside to be x squared minus 3. Then you're going to multiply by the derivative of the inside, which is 2x. Now just plug in 2. You got f prime of 2 equals h prime of 2 squared minus 3 times, you have 2 times 2 is 4. So this is going to simplify to 4 times h prime of 2 squared is 4 minus 3 is 1. 4h prime of 1 matches up with choice B. So this next question here is a little bit tricky. We have the line x plus y equals k. K is constant, and this line is tangent to the graph of this quadratic, and we want to know what the value of k is. So just think of a quadratic like this, a positive x squared looks like this. And one thing to note, if this is the tangent line, that means it's going to touch this curve at exactly one location. And what I do for something like this is I solve it for y. Y equals negative x plus k. And you have to imagine that if this is the tangent line, the slope of the tangent line is going to match the value of the derivative at the point of tangency. So what that means here is if we identify the slope, so the slope, our m value, is equal to negative 1, I imagine that on this curve that the slope is going to be equal to negative 1 at a spot like this. Okay, so this is kind of what I'm envisioning here, that our tangent line has a slope of negative 1 at exactly one location on a parabola like this. So then I want to know, all right, what is the value of x and y where this occurs? So what we're going to do is we're going to take the derivative of this equation, because the derivative y prime is going to tell you the slope at any location. So the derivative is 2x plus 3, but we want to know when exactly is the slope or derivative equal to negative 1. So now just set the derivative to equal negative 1, and we get 2x plus 3 equals negative 1, and now just subtract 3 on both sides. You get negative 4 equals 2x, which gives you x equals negative 2. But now that just tells us the x coordinate here, that this point of tangency, the x is equal to negative 2. We still have to know what is the y value. So we could plug x equals negative 2 into the original equation to get the y value. So we have y equals, and we're going to have negative 2 squared plus 3 times negative 2, and then plus 1. So this is going to give us y equals 4 minus 6 plus 1, and negative 2 plus 1 equals negative 1. So that's our mystery y value here. So we're at the point negative 2, negative 1. So if we want to know what the value of k is, well, x plus y is equal to k. And once again, a curve and the tangent line share the point of tangency in common. So this will help us find the value of k. So all we have to do here is just plug in. So we have x, which was negative 2, plus y, which was negative 1, is equal to k. So this tells us k is equal to negative 3 for this question. This is going to be choice A. So question 19 is very, very, very tedious. So what you have to do here, this is partial fraction decomposition. So you take the integram, which is a complicated expression, and we're going to break it into two simpler fractions. And we don't know what the numerator is, so that's why we're going to say a over the first factor is 2x minus 3 plus, and we're going to have b over the second factor here is x plus 2. So the algebra involved, just know these questions are like 95% algebra. You'd have to multiply this fraction by the missing factor x plus 2 on top and bottom. And then you'd have to multiply the second fraction by the missing factor, which is 2x minus 3. So once you do this, now all three fractions have the same denominator. So in a sense, the denominators just all wipe out. And what you would be left with, you'd be left with 7x equals a times x plus 2 plus b times 2x minus 3. Now from here we want to solve for a and b. So there's a few ways we could do this. You could do a system, or you could plug in test values for x. And the best test values to use are the ones that make the factors go to 0. So if you plug in x equals -2, you get 7 times -2 is -14. And this is going to equal a times -2 plus 2 goes to 0. So this cancels out. Plus b times 2 times -2 is -4, minus 3 is -7. So now we simplify, we got -14 equals -7b, and that means b is equal to +2. So now we have one of the values here that we need. Now we just have to solve for a. So what we could do to solve for a is we could plug in the other x value that makes this factor go to 0, which if you solve 2x minus 3 equals 0, you'll get x equals 3/2. So when you plug in x equals 3/2, you do 7 times x, or 7 times 3 over 2. You get 21 over 2 equals a times, you got 3 over 2 plus 2, plus, and when we plug in 3 over 2, this is going to go to 0 here. So now this one cancels out, and we've got 21 over 2 equals 2. Another way of saying 2 is 4 divided by 2. So now we have matching denominators. So this is going to give us 3 plus 4 is 7 over 2 times a. And now here I would multiply both sides by 2 to wipe this out. And then 21 equals 7a. That's true when a is equal to 3. So now we get here. And once you have the value of a and b, this algebra that I did up here, I honestly just do this stuff in my head, because then there's less clutter and it tells me how to break up this integral. So the original integrand, now we could break it up into two separate integrals. So this is now the integral dx, and instead of saying this, I could say integral dx, but a I could replace. A we just found is equal to 3. And then this is going to be integral dx. So this is finally where the calculus comes in, is at the very, very end. So I'm going to have here that b was equal to 2. That was what was just previously there. We're replacing b with 2. So now we did all the algebra, but now we just have to do the calculus. The antiderivative of 3 over 2x minus 3 is going to be 3 natural log absolute value 2x minus 3. But there's a little trap here. You have to know, because the denominator is 2x minus 3, when your denominator like this is linear, you're going to say the derivative of 2x minus 3 is 2. So you just have to divide your antiderivative by 2. Otherwise, what you'd have to do is you'd have to go on the side here and say, all right, 3 over 2x minus 3 dx. You'd have to do a u substitution. And this would just be a very tedious process. I mean, it's not wrong to do this, but it's just much faster if you just use this idea that when your u term is linear, you could do the u substitution in your head if you just divide at the end by the derivative of your u term. Okay, otherwise, if you'd rather do it this way, you'd have 3 times du over 2, and then this is over 2x minus 3 is u. So this is where we would get 3/2 du over u, which would essentially give us the same thing we have over here. So now what we have is plus the antiderivative of 2 over x plus 2 is 2 natural log absolute value x plus 2. And then we just tack on our plus c at the end. So for 19, we just look for our answer, and it's going to match up with choice A. Choice B is so evil, because if you did all this beautiful work, but then you just forget to divide by the derivative of 2x minus 3 at the end, you would get this one. So just please be careful, because those tiny details really matter at the AP test. Question 20 is a really fun question, because there's a really fast way to do this. But the fast way is you have to show up to the AP test knowing the Maclaurin series for e to the x, sine x, and cosine x. It's going to be one of those three that they'll just expect you to know. And for this year, it was e to the x, because the Maclaurin series for e to the x is equal to 1 plus x squared over 2 factorial, and then we'd have plus x to the third over 3 factorial, and this pattern continues. So if you look at the question here, notice that this is the same thing as the Maclaurin series for e to the x, except instead of x, there's a natural log 2 in place. So what this tells us is that we're looking for e to the natural log 2. So the e to the natural log 2 would be us replacing all of these x's with ln2. So this would be 1 plus natural log 2 plus ln of 2 squared over 2 factorial plus, and then this would go on and on. And now, if we notice here, all you have to do is just simplify this. What is e to the natural log 2? Well, e and natural log are opposites, so they cancel out. So this is an expansion for 2. This would just simplify to 2, so this is going to be choice C. Question 21, we have a particle moving along a straight line, and we have a graph of the position from 0 to 6. We're told we have horizontal tangents at t equals 1 and t equals 5, and we have a point of inflection at t equals 2. That's going to be over here. We want to know for what values of t, and this is the million-dollar phrase right here, is the velocity of the particle increasing. So velocity increasing means acceleration is positive. So now we think we have the graph of position. How do you go from position to acceleration? The second derivative of position is equal to acceleration. So another way of rephrasing this question is we're looking for when the second derivative of our graph is positive, and the second derivative is positive when your graph is concave up. So what you really have to know here is what does it mean, or what does it look like when a graph is concave up? Well, that's when the graph smiles at you. So that's why they told us we have a point of inflection at t equals 2, because notice the graph starts off smiling and it stops smiling exactly at t equals 2, and it switches to a frown for t equals 2 and greater. Okay, so velocity is increasing up to t equals 2, and then it starts to decrease. So it's smiling from 0 to 2, so we're going to go with choice A. 22 was a tricky question. So we have values for f, f prime, g, g prime, and we're told if the integral from 0 to 1 of f prime g equals 5, then we want to know what is this equal to. So this is the thing that we're trying to find. And for this question, we're going to use integration by parts. So it helps to know the integration by parts formula. So for something like this is once again what we're trying to find, but we could assume this. So if this is the thing we're trying to find, the integral from 0 to 1 of f of x times g prime of x dx, this is where I'm going to start defining what is my u term and my dv term. Now, the goal is to wind up with the expression in blue so that we can make a substitution. So here, I would let u is going to equal f of x, and then dv is going to equal the rest of this integral, g prime of x dx. Now, the reasoning behind this is because I have to calculate du, which is going to be f prime of x dx, and then v is going to be equal to g of x, because that's the antiderivative of g prime. So the reason why these aren't reversed is because if I let dv equal f of x, I don't know what the antiderivative of f of x is based on the table, but I do know the antiderivative of g prime is g, and that's given to us in the table. So that's why I thought to try this way first, which actually does make the question work out. So now the integral in purple, I could say is equal to, and we're doing u times v. This is based on the formula. So we have f of x times g of x, and this is being evaluated from 0 to 1 because this is a definite integral. And then we have minus the integral from 0 to 1 of v times du. That's this times this. And notice what we get. We get g of x times f prime of x dx. And we have to think, does this look familiar? Well, f prime times g times dx over here is exactly equal to 5. So whatever this works out to, it's just going to be minus 5 at the end, because this integral, once again, matches the stuff that we were given here in blue. So this was given to us. So now we just got to find this part. So we'll write this in a different color. This is going to be a little bit annoying, but this is going to be f of 1, g of 1, minus f of 0, g of 0. So now we just have to plug in, and I'll write the rest over here. I know we're running out of space a little bit. So f of 1 is equal to 4. So this is going to start off as 4 times g of 1 is equal to 3. So we have 4 times 3 minus f of 0 is equal to 2 times g of 0 is negative 4. And then we have minus 5 at the end. So this is going to give us 12 minus 8 becomes plus 8 minus 5, and you get 20 minus 5, which is equal to 15. So this is going to work out to choice E. So question 23 reinforces that idea from before, that we really have to show up knowing the Maclaurin series for sine x, cosine x, and e to the x, because they want us to find the Taylor series for f about x equals 0, which is really just us looking for the Maclaurin series. This is another way of saying it here. But we're finding it for x sine 2x. So if you start with the basic one, sine x, we have to show up knowing this is x minus x to the third over 3 factorial plus x to the 5th over 5 factorial, and then we would have minus x to the 7 over 7 factorial, and then plus this would go on and on. So we could build this from scratch, but once again, it makes life much easier if you show up knowing this. So then we'd have sine of 2x. If you replace every x with 2x, now you have 2x minus 2x in parentheses to the 3rd over 3 factorial, plus you'd have 2x in parentheses to the 5th over 5 factorial. So we're just using composition of functions here to build this series. And then we get over 7 factorial, and then this goes plus dot, dot, dot. This just goes on and on. So now what we could do is simplify this a bit. Sine 2x equals, and you have 2x minus, you're doing 2 to the 3rd power is 8. So you have 8x to the 3rd power over 3 factorial, plus 2 to the 5th power is 32. And then you have x to the 5th power over 5 factorial. Minus, and then when I want to find 2 to the 7th, 2 to the 5th is 32, so just do times 2 more times, and you get 64, 128. So you get minus 128 x to the 7 over 7 factorial. But we're not done here. Like, we expanded this a little bit. We still have to throw in that x in front. So now the final piece would just be, all right, x sine of 2x. And you would get that by multiplying everything here by x. So if I multiply 2x by x, I'm going to get 2x squared. Minus, now I would get 8x, and I would just bump this up 1 power to the 4th over 3 factorial. And then I have plus 32x to the 6th power, because once again, we're multiplying by x to the 1st, so it just bumps everything up by 1. 32x to the 6 over 5 factorial. And then I have minus 128 x to the 8 over 7 factorial. So now I just have to go searching through the answer key for our answer. And this looks like, if we keep looking, we finally get down here to choice E. This is going to match what we have. So this question is going to be choice E. For question 4, we have a logistic differential equation, and we want to know which of these equations would model the graph above. So we'll just zoom in a little bit for this one. And the trick to these questions, it really does help if you know the equation for the logistic differential equation, because when you do this, this helps you eliminate choices right away. So I could see that these are the two main forms of a logistic differential equation, but for this question, it looks like it's going to use the second one, so we could kind of just ignore this one for now. And right away, because this is the general form of a logistic differential equation, notice if I distributed this, I would have KPL minus KP squared. So the square should come after the minus sign, which allows us to eliminate choice C because the square is coming first. It allows us to eliminate choice D. And then choice E, there is no subtraction going on, so we could just eliminate choice E right away. All right, now the next idea, you could do a bunch of factoring and see that which one it's going to match, but this idea that I'm about to write down I find to be most helpful for these questions. And you have to notice the trend. As t goes to infinity, two things happen. We're heading towards a y value of 200, or in this case, the name of the y-axis is the p of t axis. So as t goes to infinity, p is heading to 200. So we're heading towards this horizontal asymptote, but another thing is happening. The slope of the curve is heading towards 0, because notice here we have a positive slope, and then after this point of inflection, the slopes start to get smaller, and they start to flatten out. So that means dp over dt, the slope of this curve, is heading to 0. So these three things happen together. But what that tells me, every time I do questions like this, it tells me that when I plug in the horizontal asymptote, which in this case is p equals 200, when I plug in p equals 200, I should get a slope of 0. So now we're going to use that idea for the remaining answer choices. And if we plug in p equals 200, well, 0.2 is the same thing. So I'm going to say here, p equals 200 is going to give us 2 over 10 times p equals 200 minus 0.001 is 1 over 1,000. And we're multiplying that by 200 squared. And on the side, 200 squared is not as bad as it looks. It's 2 times 2, which is 4, but now there's going to be 4 zeros. So we just put 4 zeros. So we'd have a 4, and then we would have 4 zeros after this. So now we have trailing zeros that we could get rid of. So now this is just 2 times 20, which is 40, minus, and we have 3 trailing zeros to get rid of. So we get 40 minus 40, which is 0. So right away, this is telling me this is most likely the answer. But just to be safe, I'm going to plug in 200 to choice B. So if we plug in p equals 200, we're going to have 1 over 10 times 200 minus 1 over 1,000 times 200 squared. And if we do 200 squared again, we get a 4. and then we get 4 zeros. So now what we're going to do is we cross off the trailing zeros, so we have minus 40. And then here, we see how this one works out. This is going to be 20 minus 40, which is equal to negative 20, which is not equal to 0. Remember, when we plug in the horizontal asymptote, our derivative should be 0. So that's how I know it's not going to be choice B. And just let's say you forget these formulas, you could use this strategy here and this mindset to answer this question and get choice A either way. But it helps to know the formula because then you could eliminate choices C, D, and E right away. For question 25, we're told that f is differentiable at x equals 2, and we want to know the value of c plus d. So we have to know here, for f to be differentiable, it also has to be continuous. And for it to be continuous, the limit on the left side of 2 has to match the limit on the right side of 2. So that means that we could plug in x equals 2 to the top and bottom and set those equal. So if I plug in x equals 2, I'm going to have 2 times c plus d, and that should equal x equals 2, we have 2 squared, minus c times 2 is 2 times c. So this tells us 2c plus d has to equal 4 minus 2c. But then the next thing here we should have is that f prime of x equals, and it's multiple choice, so my work is going to be informal. The derivative of the top of cx plus d with respect to x, c and d are constants, is just going to be c. And this is right now for x less than 2. Now, they told us that the value of c and d is going to make this differentiable, so I could include the 2 here because we're going to be differentiable at 2. And then I have the derivative of the bottom is 2x minus c, and this is a strange derivative, but remember, c and d are constants, so this makes sense. So for the function to be differentiable, that means the left and right side limits of f prime at x equals 2 also have to be the same. So if I plug in x equals 2 to the top, there is no x, so I just let the left side is just going to be c. And then when I plug in x equals 2 here, I'm going to have 2 times 2 is 4 minus c. And now to solve for c, just add c to the other side. You get 2c equals 4. So c equals 2. And if c is equal to 2, now we could plug c equals 2 into this equation here and solve for d. So 2 times 2 is 4. You get 4 plus d equals 4 minus 2 times c, or 2 times 2 is equal to 4. So now you have 4 plus d equals 0, which tells you that d is equal to negative 4. So then the last thing to do here, be careful. It's not 2 and it's not negative 4. They want you to find the value of c plus d. So if you do 2 plus negative 4, this is equal to negative 2. So our answer here is going to be choice B. So for question 26 here, just know that's the y-axis up there. That what we have is we want to know which expression gives the total area enclosed by the polar curve r equals sine squared theta, shown in the figure above. So just know the formula for area under a polar curve is 1/2, and from theta 1 to theta 2, we have r squared d theta. So for this question here, my best advice, because these are a little bit tricky to type into a calculator, is I think about what's going on here at a few of these directions, like let's say theta equals 0. If you plugged in theta equals 0, and I'll make a quick table for, let's say we have theta and we have r. Theta equals 0 is going to give us sine squared of 0, which is 0. So you could see that in this direction we're starting here. But then if I go up to pi over 2, I would get sine of pi over 2, which is 1. And when I square that, I get 1. So you see how at pi over 2, we're here. And now this tells me what we need to know here, that at pi, sine of pi is 0. It brings us back here. So the path from 0 to pi, see, this is at theta equals pi, would give us the area of the top part here. And I'll change colors for this. So from 0 to pi would give us one of these. So if I want to know the area of all of it, I could just double this because this is symmetric. So if I do the area, and now we have the formula, we have 1/2 integral from 0 to pi, and r squared. R is equal to sine squared theta. So this is being squared. And we have d theta. Just remember, I want the total area. So I have to multiply this whole thing by 2 because this part here is only the top half. So that's why we have to double it. And then 2 times a half cancels. So this is going to work out to the integral from 0 to pi. Sine squared squared is sine to the 4th of theta d theta. So now we just look for this answer choice, and this is going to match choice D. So for question 27, we want to know which of the following could be the slope field for this differential equation here. Now I'm going to scroll down to look at the rest of the answer choices, but my strategy for these kind of questions is the first thing I look for is when is the derivative or the slope equal to 0. And in this case, dy dx would be 0 when the derivative y squared minus 1 is equal to 0. And this is true when y equals plus or minus 1. So this information, how does this help me with the question? Well, I'm looking for a 0 slope. And a 0 slope on a slope field is just a bunch of horizontal lines like this. So what I look for is along the line y equals 1. So y equals 1, I think of this line, and y equals negative 1, I think of this line. If I go here, and you might not be able to see that, so I'll make this bigger. This is going from negative 2 to 2. Y equals 1 would be in this range here. And if you look really carefully, these slopes, see, these are like slightly positive, slightly negative. So see how it looks like we have a bunch of 0 slopes that would go in between like this. So this is looking good. And if we look at y equals negative 1, we have the same thing going on. In this little space here, we have what looks like would be a bunch of 0 slopes. So my first instinct is to say that A is the answer, but for something like this, I highly recommend that you go through the other answer choices and show why they're not correct. That's a really good strategy to use for the AP test, is you have to be able to say why the wrong answers are wrong. So if we look along y equals 1, which is this horizontal space here, notice we have a bunch of non-zero slopes. See, like this is positive, this one here is positive, we have negative here, negative here. They're not all 0 like it was for choice A, so this one's out. And if we scroll down just a little bit, let's say we look over here, and I'll make this darker, so we're at 2 and we're going down to negative 2, that in this space here, what we have is we have a negative slope. This part here, we have a negative slope, so they're not all 0, so C is out. And if we go to this space here, same thing, this is going from negative 2 to 2. If I look in that y equals 1 space, I have a bunch of positive slopes here. Okay, so this is all positive stuff. They should all be 0 in that space, so choice D is out. And now we'll do the same thing here for the last one. So if we look down here at choice E, for choice E, if I look at y equals 1, that's this space here, I have a bunch of positive slopes where they would all need to be 0, so choice E is out. So this gives me full confidence here that the correct graph is going to be the graph in choice A. Question 28 might be the most evil question on the whole multiple choice part A. So for this one, you just have to go very carefully. We're told we have a particle moving along this parabola. And this is not part of the question, but for something like this, I had to really understand what was going on. So I factored this, and that told me that a rough sketch of this, we would have a root at 0 and a root at 1. So if I look at a whole picture here, this graph looks something like this. And they're saying that the particle is moving along this curve, and it's at the moment at the point 2, 2. And dx dt is positive, which means this particle is moving in this direction here. Like it's moving up the parabola this way. But what we're told is it's traveling at a constant speed of 2 radical 10 units per second. So what I think of is that speed, I call dz over dt, is equal to the square root of, and it's parametric, so it's going to be the square root of dx dt squared plus dy dt squared. But they told us that the speed is constant. It's 2 radical 10. So I have 2 radical 10 equals the square root of dx dt squared. And then we have plus dy dt squared. So for this question, what makes it challenging is that initially it seems like it's going to be impossible to get this to be a single variable, because right now we have 2 variables here equals something else. So how do we get it down to 1 variable? And the trick is that we have to start with the equation y equals x squared minus x. And we're going to take the derivative of this thing with respect to time. So the derivative of the left side is going to be dy dt. And the derivative of the right side, we could do the derivative of x squared minus x is 2x minus 1. But each of those pieces is going to get an extra dx dt. So this is like the concept behind related rates that's applying here. So we just have to make sure we use the chain rule because we're taking a derivative with respect to time, not x or y. So from here, we have to be mindful that when the particle is at the point 2, 2, so that means x is equal to 2 and y is equal to 2. So x equals 2, y equals 2 implies that dy dt equals 2 times 2 is 4 minus 1 is 3. So this is 3 dx dt. So then what we want to do from here this is where things get a little tricky. We want to solve for the value of dy dt. So I'm going to make a replacement here. I'm going to do a substitution into the equation in purple, but I want to replace dx dt in terms of dy dt, so we could just solve for dy dt right away. So I'm going to take this equation, and what we're going to do is we're going to multiply both sides by a third, and we'll have 1/3 dy dt. So just make that neater. 1/3 dy dt is equal to dx dt. So we just, in a sense, divide both sides by 3, or multiply both sides by a third. So now we're going to substitute into the equation in purple. We're going to have 2 radical 10 equals the square root of dx dt. We're replacing with 1/3 dy dt, which, you know what, I could call it dy dt divided by 3. So this whole thing is in parentheses here being squared, and then we're going to have plus dy dt squared right next to it. So once again, we just made a substitution. 1/3 dy dt is the same thing as dy dt over 3. So this becomes 2 radical 10 equals, and dy dt over 3 squared is going to be, we're going to make this radical bigger, is going to be dy dt squared over 3 squared is 9. And now this is going to be plus dy dt squared right next to it. But what I want to do is combine like terms. These are like terms, but this has a coefficient in a sense of like 1/9. And this one, I need to make common denominators. I'm going to make 9/9. And let's be mindful here, if I extend this square root is going all the way through those denominators. So we'll just make space here. So let's just get rid of this space here, and I'll just extend that down. So this square root is covering the denominators as well. So then what we're going to do from here is we're just going to simplify what's in the radical. We have 2 radical 10 equals, so we have 1 dy dt squared over 9 plus 9 dy dt squared over 9. That's going to make square root of 1 plus 9 is 10, and we have dy dt squared over 9 like this. So now what we're going to do is we're going to take the square root of whatever we can. So we'll just write the rest over here. This is going to give us 2 radical 10 equals, and the square root of 10 isn't going to go anywhere, but the square root of dy dt squared is dy dt, and then the square root of 9 is 3. And then right next to it, the square root of 10 cannot pop out, so it's just going to stay as the square root of 10. And now, right away, what I see is we could just multiply both sides. So we'll do this in a different color. We could multiply both sides by 3 over radical 10, and this will simplify, times 3 over radical 10. On this side, everything cancels except dy dt, which is what we want. So we have dy dt equals, and on this side, radical 10 cancels, and 3 times 2 is equal to 6. So our answer, dy dt, is going to be equal to 6. Okay, well, this is going to conclude this video on the AP Calculus BC 2008 Multiple Choice Part A. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.